Hello all, welcome to the first lecture of partial differential equations. Actually this is a part of third semester MSc Mathematics course PDE and integral equations. So in that course PDE and integral equations, the first two modules deals with the partial differential equations and the mainly of first order and second order equations and a special type of partial differential equations and their solutions, etc. Okay. And the two modules are from based on the textbook An Introduction to PDE Partial Differential Equations, An Introduction to Partial Differential Equations by the authors Yehuda Pinchover and Jacob Rubinstein. Okay, so these lectures are based on this textbook, An Introduction to PDE Partial Differential Equations by Yehuda Pinchover and Jacob Rubinstein. So in order to explain more about this course or this PDEs, first of all we want to know what is a general PDE and what is meant by a PDE and what are the different types of PDE and where they comes and how can we identify or how can we recognize a PDE from a ordinary differential equation. So for that we are going through some preliminaries. First of all, basic definitions. So a partial differential equation, PDE means it is partial differential equation. So this actually describes a relation between an unknown function and its partial derivatives. So a partial differential equation is actually it is a relation between an unknown function and its partial derivatives, and they occur frequently in all areas of physics and engineering. And in recent years we have seen that a dramatic increase in the use of PDE in the areas such as biology, chemistry, computer science, etc. and etc. And also in finance also. Okay, so in modeling problems we are mainly using PDEs. So modeling problems also we are using PDE. So first of all we have to identify what is the general form of a PDE. So the general form of a PDE of a function of an unknown function u of x1, x2, etc. xn is given by f of x1, x2, etc. xn u comma x1 u at x1 u at x2 etc. u at x1 x11 etc. equal to 0. That is taken as equation 1.1. അതായത് ഒരു ജനറൽ പാർഷ്യൽ ഡിഫറൻഷ്യൽ ഇക്വേഷൻ എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ അത് ഒരു ഓർഡിനറി ഡിഫറൻഷ്യൽ ഇക്വേഷൻസ് എന്നുള്ള ചേഞ്ച് എന്താണ്? ഒരു ഓർഡിനറി ഡിഫറൻഷ്യൽ ഇക്വേഷനിൽ ഒരു ഇൻഡിപെൻഡൻറ്റ് വേരിയബിളും ഒരു ഡിപെൻഡൻറ്റ് വേരിയബിളും ആണ് ഉണ്ടാവാറുള്ളത്. ജനറലി ഒരു ഇൻഡിപെൻഡൻറ്റ് വേരിയബിൾ ആണുള്ളത് അല്ലേ. സോ y ഈസ് ഈക്വൽ ടു ഫോർ എക്സാമ്പിൾ y ഡബിൾ പ്രൈം ഓർ y ഡബിൾ ഡാഷ് പ്ലസ് 3xy dash plus 2x is equal to 3y square. Okay, so this is a this is an ordinary differential equation. So here y double dash means it is d square y by dx square. So y is depending on the x. Here the unknown function is y and which is the independent variable and its derivatives are coming in this equation. That is only the not the partial derivatives because there are only one unknown independent variable x. Okay, so if there is only one independent variable then that equation will be the ordinary differential equation, whereas a partial differential equation involves more than one independent variables. Or this is a relation containing function and an unknown function and its partial derivatives. Simply we can say like that. It's a relation between one unknown function u. So here in this example, the unknown function is u, which is defined in terms of x1, x2, etc., xn. So the variables x1, x2, etc., xn are called the independent variables. These are the independent variables, and u is defined in terms of x1, these n independent variables, and u is the unknown function. U is the unknown function, and here ux1 means dou u by dou x1. Ux2 implies u suffix x2. U suffix x2 means dou u by dou x2, or in general uxi means dou u by dou xi for I equal to 1, 2, 3, etc. up to n. So this represents the partial derivatives of the unknown function u with respect to the variable or independent variable xi. So this equation 1.1 gives a general form of a partial differential equation. It's a function containing the independent variables x1, x2, etc., xn, the unknown variable u, and its partial derivatives ux1, ux2, etc., which is equal to 0. So this is known as a partial general form of the partial differential equation. Now we may discuss about the well-posedness of a partial differential equation. When can we say that a partial differential equation is well-posed? So our next definition is well-posedness of a partial differential equation. When can we say that a partial differential equation is well-posed? Actually, the term or the notion of well-posedness was coined by the French mathematician Jacques Hadamard. The term was coined by Jacques Hadamard. And hence this condition is also known as Hadamard condition. So this is also well-posedness is also known as Hadamard condition of a PDE. Hadamard condition for well-posedness of a PDE. According to his definition, a problem is said to be well-posed if it satisfies the following criteria. A problem is said to be well-posed if it satisfies the following criteria. Which are the criteria? Number 1, existence of a PDE. Number 1, existence. Existence means the given problem must have a solution. Existence means by the existence of solution. That is, the given problem has a solution. So this is meant by the existence. And the second criteria is uniqueness. Uniqueness, that means the solution, if it has a solution, if there exists a solution, then it must be unique. That means there is no more than one solution. There is no more than one solution. And the third property is stability. So stability means A small change in the equation or in the side conditions give rise to only a small change in the solution. So this means a small change in the equation or side condition, that means either the initial or boundary conditions given with the equation or side condition gives rise to a small change, negligibly small change in the solution. So if a partial differential equation satisfies all these three criteria, then it is said to be a well-posed partial differential equation. If at least one or more of the conditions does not hold, then we say that the problem is ill-posed. Otherwise, we say that it is ill-posed. If one or more of these three conditions fails or does not hold, then we can say that it is an ill-posed PDE. Next is we have to discuss is classification of PDE. Classification of partial differential equations. Actually, there are different types of classification related to different properties or different criteria, and some classifications are according to the order of the equation, some are according to the degree, that is the linear, either linear or non-linear type. So now we have to discuss all these classifications that we can discuss, that we can do in the next video. Okay, so let's stop here. Thank you.